Today, we're going behind the lens. We're going to see the invisible intelligence that's powering the cameras that watch, well, pretty much everything in our world. I mean, just think about it. From city squares to your local college campus, video surveillance is absolutely everywhere. It's a massive industry, too, projected to be worth over $108 billion by 2030. And all those cameras? They're generating a total fire hose of data every single second. So that's the real question, isn't it? Today, we are going deep into the powerful AI that gives these cameras a brain. We're going to uncover some of its surprising flaws and explore the really radical, kind of sci-fi ways it's now being taught to understand our world. Okay, so let's start with the breakthrough tech that makes all of this possible. This is the engine behind all modern, real-time video analysis. It's called YOLO, and yep, that stands for You Only Look Once. And that name tells you everything. See, before YOLO, AIs had to look at an image multiple times just to find all the different objects. YOLO? It does it all in a single pass. And that one little change completely revolutionized the game for real-time object detection. So how does it work? Well, the process is actually surprisingly elegant. It really just comes down to 3 simple steps. First, the AI carves up the image into a grid. Then, each little cell in that grid takes a guess at what it might be seeing. And finally, there's this really intelligent cleanup process that gets rid of all the duplicate predictions. And that 3-step dance is the secret sauce to its incredible speed. And that speed, well, it's unlocked a whole world of applications that are already reshaping our public and private spaces. We're talking about everything from managing traffic flow and securing airport perimeters to analyzing how we shop in retail stores. It's everywhere. But here's the thing. This powerful new vision, it isn't perfect, not even close. And when it fails, the consequences can be incredibly serious. So let's look at where this all starts to break down. On a beautiful, clear day with a perfect, unobstructed view, the AI sees pedestrians with amazing accuracy. It really does look flawless. But what happens when things get in the way? This is a huge problem called occlusion, and it is a major, major weakness for these systems. The moment you start hiding parts of a person, look at that chart. Performance just nosedives. Some of the best models out there go from being nearly perfect to failing completely when a pedestrian is even partially blocked from view. And you know, this isn't just some abstract academic problem. For a self-driving car that's trying to navigate a busy city street, failing to see a partially hidden person isn't a data error. It's a potentially fatal mistake. And there's another huge challenge, something called streaming perception. You see, even the fastest AI has a tiny processing delay. And that means it's always reacting to a world that existed a few milliseconds ago. It's always playing catch-up. That tiny lag creates a critical mismatch between what the AI thinks it sees and where things actually are in the real world right now. So these technical glitches, these blind spots, they actually open up an even bigger can of worms. The profound ethical questions that this technology raises for all of us. We're really walking a tightrope here. On one side, you've got this incredible promise of enhanced security and safety, which is super compelling. But on the other side, it comes at the cost of this pervasive, constant surveillance that, let's be honest, most of us never really signed up for. And this brings up some really tough questions. First, there's the whole issue of consent. I mean, most people have no idea this kind of analysis is even happening. Then, there's the question of what happens to all this data and how it might be used or misused down the line. And finally, there's a huge concern in the field about algorithmic bias, where these systems can actually inherit and even amplify our own human biases. And that brings us to a really crucial point that researchers like Dr. Riyad Subhani have pointed out. These systems aren't just neutral observers. They can become a mirror, amplifying existing societal biases. The thinking is pretty simple. If the data you train the AI on has flaws and biases, well, the AI's decisions will have those same flaws and biases, which can lead to really serious, real-world consequences like unjust profiling. So, faced with all these technical and ethical challenges, what do? Well, researchers are turning to a surprisingly creative and, frankly, pretty radical solution to make these AI systems smarter, safer, and maybe even less biased. You see, the biggest problem in training an AI has always been data. To teach an AI to see our world accurately, you need a massive, perfectly labeled dataset that covers every possible scenario you can imagine. And trying to create that from real-world photos, It's a nearly impossible task. It's slow, it's expensive, and it's always full of human errors. So, what's the radical answer that this research paper highlights? Simple. Don't use the real world at all. Instead, use a video game. Yep, researchers created a dataset they call VPED, the Virtual Pedestrian Dataset, using thousands of images from the hyper-realistic game Grand Theft Auto 5. And this is where it gets absolutely amazing. The AI that was trained on the virtual VPED dataset from GTA 5 actually performed better than models that were trained on two of the biggest real-world image datasets. The virtual world beat the real world. I mean, just let that sink in for a second. What this really shows is that by creating a perfect synthetic world, a world where every single car, every pedestrian, every object is perfectly labeled automatically, we can actually teach an AI to overcome the messy, unpredictable, and often incomplete data from our own reality. It's like giving it the ultimate cheat sheet. So all of this leaves us with one final and really crucial question. The technology to see and understand our world is advancing at a breathtaking pace. By training AI in these virtual realities, we can overcome its blindness. But that just puts the responsibility right back on our shoulders. As AI learns to see our world with more and more clarity, what exactly should we be teaching it to look for? And maybe more importantly, who gets to decide?